Hi, everyone.
Hey, magic.
How's everyone Friday?
Good. Hey, Bobby. Hey, Queen.
Good morning.
Morning.
Okay.
Hi, Bobby.
Hey, David.
Hi, Bobby.
Hey, just check your email for a second.
Okay. I saw an exchange. Yes.
No, a brand new one from 1 minute ago.
Sure. Why not?
You sure?
Yeah.
All right.
Do you have somebody in mind?
Nope. I'm just going to check.
Okay. As long as we hit the chiplet summit with the paper, it's all good. Did it go to full screen mode or is it still showing the slide?
Full screen.
Okay, awesome.
So, Bappy, did you say that you shared this draft or?
No, not yet. I think this is still under review with the team writing it.
Yes.
So once it's developed, once it's released as an official white paper, I think David will share with everyone.
Correct.
And our hope is sometime in the next sometime in the next month, by the end of by either the early in January or mid-January is when we'll release this, or when they will release this. There's no we here. But the discussion David and I had offline is whether anybody is interested in reviewing the white paper upfront. But we actually need an actual review. So somebody who wasn't involved in the development. If anybody's interested, either ping me by email or David by email.
Good morning, Bapi. So what's involved in the review?
Well, considering it's a brand new idea, it's something in it is the reading this thing as a sort of a new recipient and just sort of saying, yep, it all makes sense. There's or suggesting any changes you want to see will make it which will make it better for the audience. Essentially seeing whether it matches the target audience.
Okay.
Yeah, we haven't defined yet who the target audience is, and I'll cover that in my presentation now.
So, David, how is this different? I'm sorry, maybe you're addressing it, but how is it different from what you have already done? This group has already done before?
I can explain that in my presentation.
Okay, great. Thank you.
Yeah.
If you want holiday reading, this is your option.
Yeah, this holiday will not be enough to read this.
Yeah, I may have some bandwidth, Bapi. I can help.
Oh, awesome. Okay, that's good to hear. Okay, so today's agenda is the CDXS group's opus. All yours, David.
Thank you very much, Bapi, for the opportunity to present highlights of the white paper that the CDX group has been working on. I want to specifically thank all the authors who have put in their free time in developing this white paper. And I specifically want to mention everybody, Boone from Intel, John from Siemens, Kevin from Cameron EDA, Li Hong from ASC, KK from Applied, Lal from Siemens, Roger from ASC, Mark from Siemens, and Tony from Siemens, Jawad from Palo Alto Electron, Rajesh from Capgemini, Joe from Siemens, Satish from Intel, and James from Palo Alto Electron. Without all these folks putting in their knowledge and collective wisdom together, this white paper would not have been possible. So as you can see from the title of my slide, really what we wanted to focus here on is the entirety of integration workflows for heterogeneous chiplet systems. Let me figure. Okay. Just a quick reminder about the charter of CDX. We really we recommend our charter is to recommend workflows, models, and ecosystem, right, and try to work towards a standardization of those. If you recall, sometime back, our first white paper was on chiplet modeling. Looking from the point of view of the chiplet vendor, what a set of models they would need to be prepared to provide upstream to the chiplet integrator such that they are successful. So this white paper is actually a follow-up on that, and it focuses on the chiplet integrator. By the way, the modeling white paper that became the basis for so-called CDK, that's the chiplet design kit, that describes what models are needed. But this white paper is looking from the other side, from chiplet integration point of view, what we need to provide, right? I'm sorry, what workflows are to be utilized for the different aspects of integrating chiplets. Why write a white paper on this? And really, I took the liberty of basically taking the entirety of the introduction section to the white paper. Right, you're all aware that chiplets are growing. There is no question anymore whether chiplets are viable or not. The question is, okay, how do we put them together? And putting together involves many different subflows, looking from STCO, thermals, mechanical, power, signal integrity, STA, how do we do STA? And one of the biggest challenges is how do we do DFT? And this white paper is meant to be a reference guide as well for folks looking at integrating chiplets together to be sensitized to what the different workflows are. Now, the target audience for this white paper is everybody, with some clarifications, right? If you are an expert in signal integrity and you're looking for deep technical solution or some new technical grounds, this white paper does not cover that. However, if you're a signal integrity expert, but are not familiar with what else is going on in integrating chiplets together, this white paper would be a perfect reference for you. And it's really meant to introduce folks to the entirety of the workflows, the different types of workflows, what goes on, and how it happens, who does what data gets transferred, right, between different people. This is white paper, as you can see at this stage, right? The complexity of chiplet integration The way it's built into this white paper is we are at 100 pages. And without covering any deep technical ground, right, without discovering anything, any breakthroughs. So just the reference flows are 100 pages. And this is why we think this white paper would be useful for everybody. It's a significant body of work with a lot of details about the different workflows that if you are not familiar with some of the workflows, this would definitely help you out. So Bapi mentioned about if somebody wants to review this and take a look and give their opinion. Before you sign up for this, remember this is 100 pages. It's not a 2-page white paper that can be reviewed quickly, and goes into quite a bit of details about the workflows. So please consider that as well. The way we handle this is the other way, the complexity, apart from the large body that needs to describe the workflows, the complexity of the chiplet integration, the way it spills is another area it spills into how many people are actually involved in implementing the different workflows. And to kind of try to simplify that, we created these personas that we referenced throughout the white paper, and you can get an idea what a given persona, what do they need to do. So each of the workflows we have, the way we have set it up is apart from describing the workflow, we describe what each persona, what they need to do, whether they're providing inputs, whether they're providing outputs, so that if you are familiar with one of the sub workflows, but kind of wondering who needs to give you some data, or where your data goes to, and who you need to talk to, just look at the summary tables of who are the providers of inputs, who are users of the output, and look at the persona and find out who that person is. So this is a nice, how do I say, kind of like a business logic work also, right, which describe how the entirety of the workflows get put together, and where the nexus points are, and who are the people in that nexus point. And you probably notice there's quite a few personas that are involved in chiplet integration. That is all due to the fact how complex and how complex the integration of chiplets is. And if I'm sure all of you have looked at chiplets and thought about it and figured out, wow, this is quite more complex than before. And yes, it is. And really the how do I say this? The complexity of figuring out the architecture, right, and in the early exploration and the predictive analysis, all these personas will be involved. This is something new for chiplets. That's what everybody is talking about, how we move everything in the flows to the left, where at the stage everything has to be decided, and a lot of people are involved. So if I was to build a team that would put chiplets together, that needs to think about how do I put the chiplets together, I'll go through this list and find out who the experts are and put them together in one room and figure out what the architecture and the flow is going to look like. Now, before I go to the next slide, I wanted to say that really in my follow-up slides, I have one slides for each of the sub-chapters in this white paper. Now, you probably realize that if it's a 100-page white paper, there's no way I can put the 20 or 30 pages for a chapter on one slide and summarize that. So I really captured some of the major pictures and flows from each section to give you a visual idea of what's going on. There's longest explanation why these flows are like that. So I'm going to go through each of the sub-chapters, show you a little nice picture for each of the sub-chapters that I was able to pull out and explain what's in each chapter. So with that,
Hey, David.
Yes, Bappi.
So this is not meant to be a trick question, but
Okay.
But clearly, like, enough people felt that this was a important thing. Can you sort of share what the group's idea was of why this white paper was needed?
So the why question is very valid. What is new in this white paper, what we believe is new in this white paper is that it captures all the workflows in one place. And you will have a reference of what the different workflows are, what are the issues that this workflow solves, and why they need to be solved and how they are solved in terms of workflow. And all of that is put into one place as a reference, so that this is a blueprint. We believe this would be a blueprint of how chiplet integration will be happening.
Perfect. Thank you.
You're welcome. So one of the big problems in chiplets is figuring out how do I if I already have a product, how do I break it up? Bappi gave a pretty interesting presentation on the Fugaku chip, but again, that's one specific application for a CPU. This chapter goes into more general terms, describing looking at the performance of the system, different components, figuring out what the performance of the different steps is. Does it meet the bandwidth and latency requirements for actual usage of the system? And then figuring out what, if I break it up one way versus the other way, will that work? The chipletization is a very interesting problem. You can break up an existing product, or you can add more chiplets, and you can add different chiplets, right? So figuring out the performance of the entire system, how it's going to work, it's kind of tricky. And this chapter addresses what the considerations are and how some of these things could be done. We also there's a nice workflow. How do we look at it from system level, right? It's not just the chips on the substrate, but really look at the entire system and see how all the different components need to be distributed, and where each component needs to land depending on the performance of the entire system. From architectural planning and analysis workflow, right? We have figured out, after figuring out what possible partitioning might look like, then we are looking at the architecture level. What is it that all we need to do, right? And it's quite a complex flow, right? On the bottom side, you'll see we're looking at the standard stuff, right? Thermomechanical power, power delivery cost, and we're looking at area and form factor, all the components. We'll be looking at different choices for different technologies for the substrate and for the chiplets themselves. We're looking at what the different IPs need to be, the die to die, and also the chip to chip, depending on what else is there in the system. And then look at scenarios and see how all of that works. And really, the output of this is pretty much ready to implement a chiplet system. with netlists, we figured out what our substrate is going to look like. We figured out all the what power is going to look like, and with that, we will be looking at implementing a specific case for the system. Thank you to Tony for providing this nice diagram. This chapter as well goes into how all of these steps and what the considerations are. Again, remember when I'm showing just one picture, remember that there's probably 20 pages behind this picture that explain, and probably more pictures as well. So I'm pretty sure I'm not doing justice to the content of this paper, but really I couldn't figure out a way to put 20 pages on one slide. And the other option was to me to read through the entire white paper, and that's not the point of this presentation. Then we're looking at functional simulation and verification. That is a very interesting topic as well, right? We're all familiar if we are working on a die, how we are going to go and validate the RTL, or how we are going to go simulate it and make sure that it works. In this case, we are talking about system level simulation and verification, right? How do we even go about doing that? What models, what considerations? We need to make sure we have a way to model all the different firmware behavior and so on. So this is the next level in verification, where we no longer have a single die. We have multiple dies interoperating together. Even if you consider a simple thing as powering up, if you have 20 chiplets with different requirements, powering up and validating that, even that is the power up sequence, even that is a interesting topic in and of itself. So verification of chiplet system is quite complex. There's a flow behind that, and what the considerations for that flow are also explored in the white paper.
Hey, David, just quickly on this for clarification. I'm reading simulation here and then hardware validation. I'm just wondering where emulation fits into this. Is it in the hardware validation, or you mean this? You mean emulation when you say simulation as well? Or?
Emulation probably will fit. So emulation, the way I think about it, is a very fast simulation.
Right.
Right. So anytime you do simulation and you have something giant, you would put it, you would hardware emulate it.
Okay.
So emulation would be applicable to all the steps.
Okay, great. So I mean, I guess the way I look at it, just personally, whether I'm right or wrong, I don't know, but simulation I see as sort of like a higher level abstraction software model, and then emulation is a gate level, deterministic real-time model.
Yes.
And generally, I think like emulation also like based on the hardware a lot of time. So simulation, I think a lot more kind of pure on the software only can be done. I think emulation, I think like there are a lot of hardware, I think like kind of component built into it. You have to know kind of like.
Yeah, that's where I read it. That hardware validation made me feel that emulation was all the way down there, where I feel it should be more in those higher levels, which I think is what David is saying it is. So, so maybe this diagram could be tidied up a little bit in that sense. Just from if or unless that's too much detail, I don't know.
I created this like diagram. Yeah, sure. Yeah, I think thanks for feedback. But I think I thought about that. But I think what I learned, I think again, yeah, most like emulation are more hardware related and right, for a lot like for better for debugging. I think what simulation, I think like for modeling, I think I'm more for verifications and kind of like.
Yeah, we can take a look. So Alan, so remember that again, there's 20 pages behind this one simple flow diagram.
Right.
Right. I'm not doing the justice. We'll thank you for your feedback, though. We'll take a look and see, make sure that we have put the emulation in the right place and we have explained it correctly. I appreciate your feedback.
Hey, David,
Yes,
one
Bob.
follow, is there a top level flow diagram saying these are the stages and this is how much we think the time and labor per stage is going to be approximately, or which can be executed in parallel, what the dependencies are? Is that nearly impossible to make?
Yeah,
Are you talking about for this simulation verification only? Are you talking about the
No,
whole
the-
workflow paper?
Bobby
The
is
white paper itself.
Bobby is talking about a full top level flow
Yeah.
with the nexus points and how long it's going to take. You know, we didn't create that, Bobby. We flattened the flow and added all the nexus points in each of the chapters. But let me, it's a good feedback, and I was actually thinking about it yesterday, whether that can be captured in a sane way that doesn't become a basically a diagram with 50 different boxes that becomes too difficult to understand right of itself, if there's a simple way to do that. So let me think about it, and I think we'll try to do something about it.
So, Papi, just curious, your this question point of view, I think where you coming from? So you see like maybe something can do in parallel from the economic point of view or from the timing point of view, right? From end to end, like how long it takes and where it can be done in faster way when doing parallel. Is that where you coming from?
No, just basic information, nothing else. Which is like, hey, the motivation is this is a complex, long duration process. So
yeah.
So the first question is really how long does it take and how much does it cost?
Yeah, Bapi, I'm pretty sure we're not going to be able to tell how much this is going to cost, right?
Right.
This is right. I'm suspecting that the durations are also going to be difficult to obtain, right? Because if you had that, how long it's going to take, you would know how much it's going to cost, and people guard that as well. But,
even to a first order, if
yeah.
you add relative complexity or saying this is going to take the more, and maybe if it's too hard, it's too hard. But if that information is available, I think it captures it sort of frames the whole effort.
Yeah.
Yeah, maybe we can bring that back to the team and then see there's an every expert on it and get feedback on that.
Yeah.
And see what they think. Yeah.
Thank you.
Physical planning of chiplets, that's another interesting topic, right? And that keeps on coming up. How do you plan this? How do you put chiplets together and different shapes, different sizes, different interfaces, even in some cases, different bump maps for the same interface? Would that be routable? Would that not be routable? Can I supply power right to the way I put chiplets together? Where do I put all my BGA pins for the final substrate? All of that. That's another major topic that's discussed in this white paper. There's quite a bit of complexity around that, and really, if there's two aspects of that. We are really looking at chiplet integrators' point of view, but in some cases you will have some ready-to-go chiplets, some you would be implementing yourself, and you need to consider, even within the chiplet, you need to consider what else is there on the outside world, how do you place it, how are we going to route it, and then at the end of the day, how you're going to sign off all of this together, right? So this chapter addresses that aspect of the integration workflow. Next chapter is really looking at power planning. Power planning is interesting topic as well. I keep on mentioning multiple times, how do I power up these multiple chiplets? They're all going to have different, they will most likely, when we get to the stage where we have true heterogeneous integration, we're going to have quite a bit of supplies. We're going to have quite a bit of voltage levels. We need to figure out where the how do we connect those, which are going to be on the same rail, depending on the voltage regulation scheme. right? What do we tie together? And one thing that is very interesting that is to explore at this stage is we would typically do a voltage scaling for performance and voltage scaling. But now if you have two chiplets on the same voltage, even if they're from the same manufacturer, but they're with different performance, you can no longer do that, right? So look at the really the power performance aspect of all of this, figure out what the power profiles look like for different scenarios, and feed that downstream into the other flows. There's quite a bit of data to be obtained at this stage, and that also considers, especially on the scenario side, right? Remember, some chiplets may be implementing quite advanced power management schemes with power going up and down, right? Power supplies being shut off. And the aspect of that is, okay, we need to understand when and how many are doing that, because we need to feed that into the power integrity exploration to figure out, okay, is power integrity for all of this for the final system going to work or not, and what do we need to do to mitigate power noise, right? So this is where the scenario definition happens. When we have the power and the different profiles, then we go and look at the 3D geometry. Remember at the beginning, even at the beginning, we've been doing in the normal architectural exploration workflows, we'll be looking at the 3D geometries, look at the physical aspect of, right, that's where the physical aspect of where the chiplets are placed, how they're placed, also comes into play, right? Because we're looking at thermal coupling. We'll be looking at different substrates, different layers, right? Different stack ups, and thermals is one of the aspects. How do we place these chiplets? What materials are we going to use? What layers? What density do we expect on the copper layers, and so on? And for different scenarios, that gets fed into thermal simulations to really tell us, okay, this is where the hotspots are. Remember, now we have chiplets together in close proximity. So one chiplet may be heating up the other chiplet. And this also comes on, it has an impact on the power performance simulation, because what we have found, there's a little bit of lag between one chiplet shutting down, and then it heats, travels to the next chiplet. So if you're implementing power performance and thermal scheme to make sure that everything is up to the right temperature, you need to consider the time aspect of this. So this is no longer trivial one die system. With multi-die system, this becomes really tricky. And on top of that, overlaid is that you will have, in heterogeneously integrated system, you will have different components with different ratings, with different operating ratings, and you need to consider all of that together in the architecture. Signal integrity and power integrity is a big topic for chiplet systems. This is non-trivial. You need to look at what kind of interface are you going to have. Are you going to have serial interface? You'll probably have serial interface. You also have parallel interface. That all of these needs to be considered. You need to consider, you cannot work only on signal integrity without considering the power integrity aspect. These parallel die-to-die interfaces with so many bit switching, there's quite a bit of noise going into the power supply, and really power integrity and signal integrity needs to be looked at as a whole. You need to consider, even at the very early stage, what is feasible. Remember, depending on the requirements for speed, what materials you're using, that will impact your routability. It will impact your physical planning. It will impact even the stack up of the substrate which you're looking at. So signal integrity, power integrity, these are things that needs to be looked at very early. There's quite a bit of work, quite a bit of pages that describe all of this. I just took a few sample pictures from the white paper to show you the level of work that has been done to address these topics. STA, this goes towards the sign-off workflows. Really, what we need to look at is, okay, we've done all of this together. We've done SAPI, but really, is STA working? So this chapter addresses that portion of that sub workflow and provides nice information about how to implement the workflow, what the different inputs are, whom to talk to, what do you get out of it.
What does STA stand for, David?
Static timing analysis and extraction.
Right, obviously. Okay, thanks.
Wait, then are you assuming that each chip gives you a little static timing model?
Read the chapter, Bapi. There is a way to handle that. Yes. Again, so there's 20 pages behind this little picture, but the depending on what you're really looking to sign off, right? Obviously, if you have a die-to-die serial interface with the SerDes, you probably wouldn't be concerned about STA, right? Because signal integrity and all that will handle it. With parallel interfaces, you probably need to consider some of the timing aspects of that. There's definitely, I can tell you on the test side, once I get to the section, I was going to mention that, but you need to consider STA for the test.
Wait,
logic
but
as well.
STA only matters if like the two sides of the chip, the two chiplets share a clock domain. If they don't share a clock domain, if they're independently clocked, it's how does STA hit you? Anyway, you can take it off.
No, STA, I think it is a heterogeneous integration. So right, STA is important because of the way your timing start, right? And then where I think the understand characteristic, I think like there's a delay, I think at a certain path and things like that. That's important, especially like, for example, when you do a bring up, when you do a power recycling and things like that.
Yeah, Bapi, there is.
Did that answer your question, right, Bapi?
Yeah, thanks.
Yeah. We do need to do STA at the full system level. There's always a signal that needs to be analyzed.
Thank you.
Mechanical is a big topic, right? This goes into manufacturing and reliability of the final system. And really, if you really want to know whether your final system would work, you need to take an early look into what the mechanical aspects of your system look like. And when I'm talking about mechanical, there are several aspects. There is the stresses which are built from heating different parts, different portions of the system at different temperatures. Then there's materials are going to expand at different rates. So you get warpage and you get stress. And will your final system be reliable? Really, you need to take a early look into what your system looks like. I know there's some conflicting in all of this. There's a lot of conflicts. For example, if you have die-to-die interface, to minimize power and to make signal integrity better, you would want to place those chiplets as close as possible. But that's bad for thermals and mechanical. Will mechanical work? Would those chiplets be interacting with each other, right? Hitting each other and one chiplet pushing the other chiplets away in its bumps, right? You need to think about these aspects, especially if we have chiplets of different sizes all across the substrate. The substrate is going to warp in different ways. So keeping that understanding how your system warps is important, and especially what mitigations you need to put in place to make sure that the final system works. For example, you have seen the stiffeners on some of the products. They are put there for a reason, and mechanical analysis will tell you what kind of stiffener you would need, where do you place it, what shape, or how thick, and so on. And test is a big topic. How do you test different chiplets? 2.5D is probably slightly easier than 3D. So this chapter addresses a lot of the questions and the work that has been done. It has a nice introduction to the different models, to the different standards. There's many different standards for testing. It gives a nice overview of what the different standards are, addresses what the workflows are, addresses what you need to think about if you want to test, right, sacrificial paths, how do you handle those, and so on. This is probably our biggest chapter. Even the pictures I took are just a few of the pictures of the workflows. Just wanted to give you a little bit high-level overview that we are addressing 2.5D as well as 3D, and we are addressing sacrificial paths, how those are connected, and gives you a nice understanding of what the test problems being solved are. At least I'm not a test expert, and this chapter has been quite enlightening to me to understand what all the test guys are doing and what kind of inputs they would be looking for and what they would be providing to me. Yes.
On the previous thing, Srijit from Intel is starting has started a new IEEE standardization effort called IEEE 3405. I guess they label it with a P. So if
proposal, okay.
Yeah. So if I got this weeks ago and I just realized I could forward it to the group. I apologize. I'm going to do that. But anybody who wants to, I'm going to have Srijit present to. He can't make Fridays, but he can make a Wednesday. So at one of the BOW meetings, we'll do a conversation on this new test activity for.
Do you know what 3405? What does it address?
Well, it just says chiplet interconnect test and repair working group.
Okay. Yeah, that's one of the things that actually I was recently asked about from some of the manufacturing and assemblers that I work with, is they're getting pushed to do finer and finer pitches, and their concern is, okay, right, what is the availability of this, right? All these connections, is there a repair mechanism, right? Because so repair.
But this is a very narrow focus. It is just
Correct.
the interconnect, not the chiplets themselves.
Yes. Yeah. Yes, understood. Right. That's exactly. And thank you for bringing that up. I think that would be interesting. And I hope everybody has realized that by now that there has to be a lane repair mechanism and remapping. I know that. It has BOW. Do you know if BOW has this in the 2.0 spec?
BOW has had it from 2006 or something, man.
Oh, really?
No, it's in the 2.0 standard. It is, yes.
Okay. Yeah, I was like, wait, that's not the one I read in 2006.
No, it's a BOW has had lane repair for about almost a year in the draft, and I think ever since the 2.0 standard.
Yes, yeah.
Just on the internal test of the chiplet, obviously, and I'm no expert in this either, but on these scan tests, you can actually turn inwardly and actually test the device internally as well, right? So you can test that you've got at least from a functional perspective as opposed to maybe a timing perspective. Is that?
Yes.
Yes.
Yeah. So there is a standard for, right, apart from scan, I believe one of the test standards addresses, okay, when you have multiple devices, how do you do scan? And there is a lot of discussion around that, is because if you're a vendor of a chiplet, you definitely don't want to give your scan vectors to somebody, right? Because from scan vectors, you can, if you had the plain scan vectors, you can infer a lot about the functionality in that chip, right? So that's quite proprietary. And I know that some of the test standards address that through obfuscation and through encryption. We addressed that in the CDK white paper, talked about specifically what a vendor needs to provide. In some cases, it needs to be a gray box net list. In some cases, it can be black box and so on. But there's yes, there are tests that right, it's scan and it's mem-based. All of these need to be included, so that when you have the final integrated chiplet system, you can test all of them and verify all of them that they're still working.
Bobby, you're going to send forward that IEEE information, right, to the same email list?
I did a minute ago.
Oh, okay. Thanks.
And my last slide, concluding with the a quote from the concluding chapter in the white paper. Really, the white paper goes into quite a bit of detail about the different workflows, what the considerations are in implementing those workflows. And really, we think that chiplets are truly the next big thing, and they have revolutionized already how we do chips and how we do systems. These are chiplets are going to enable a lot of the next level computing. Some of the things that we would not have been possible before are truly enabled by the chipletization, and that's why we talk about chiplet era. This describing the workflows, how do you put all of this together, is one of the is our contribution. We hope that it's useful to a lot of folks. And thank you very much. I answered some of the questions. Does anybody else have questions, please?
Very good, David. Bapi, I'd be happy to see if I can find some time over the vacation period, over the Christmas period, to review it.
Okay, so then we've got 2, and I'm going to sign up. So that's 3. I think that meets our needs, right, David? 3 is good.
Perfect.
Anshu, Alan, and I volunteer, unless somebody else also wants to volunteer. But I think
No,
we have a start.
Probably enough. Yep, good start. And Bapi, I'll talk to you offline about the logistics to get this published.
Yep.
Okay. All right. I almost filled the entire hour. I was afraid that I'm going to go through this in 15 minutes. So thank you for asking me questions that I can clarify.
One thing though, I think I want to share and highlight here also as well. One thing nice about this white paper is that we also included the input and output tables for every chapter, every workflow. And that input output, it describes like what are the information that are required for the as input for that phase. Like for example, when you do verifications or when you do like physical design or testing, and then that including the persona, and then description about it, and then including the output of that workflow, and such as like there's certain like file format, or there's certain like the models or certain standard, right, ECXML, right, or CDXML that might be helpful in every stages. I think that probably another. I think it's a nice kind of like information. I think useful. I think for people. I think looking to implement things like this new chiplet workflow.
Oh, brilliant, man. That was actually going to be my next question. Brilliant. So that thing can actually become the picture that we were that we were discussing.
Yes.
Yeah, David, you have that. Can you want to quickly show that a few examples then, or I have pretty sure that.
Yeah, that I don't have the presentation, the paper ready to go. I only have the slides, but you will see it in the final. So, Bapi, you are going to review the paper, so you can see what we've captured.
Yes,
Yeah.
I definitely will.
Yeah, or maybe yeah, David, if you can allow me to share quickly, or
yeah, go ahead.
I think I cannot.
Yeah, this is the Wild Wild West, man. Anybody can grab the screen.
Oh, really? I said I can
Yes.
start screen sharing other participants. Now I can.
Okay. Maybe I needed to unshare.
Yes.
So it's partially Wild Wild West. Whoever takes the screen, nobody else can share at the same time.
Right. So can you see my screen?
Yes.
So I think I think just want to highlight. I think I create all this chapter. I think David has shown. So I think every end of chapter you can see there's an input output description here. And we jump into it. For example, one of them here, right? This is for the partitioning chapter. So you can see, right, input output description. So the input target system requirement, and then there's a personas, and then there's a description like source for target system, etc. And then the next table is showing the outputs, like refined and formatted requirement documents, architecture specifications in PDF, and then like again there's a persona, like the SA is a system architect. So same things. I think if you just go down, I think every chapter has the input output. I think that's one of the way. I think if you guys, some of you, I think if you don't like to go in details every chapter, I think one summarize other than the picture. I think it's a good input and output table that give you information. I think what other requirements here. I think that may be needed, and that will be done here. I think that gives some idea, and that description give you what this information are using for, right? And some analysis and simulation that has been done here. So I just wanted to quick.
Oh, this is incredible. Thank you. Hey, would this be better as a wiki rather than a PDF?
We thought we were going to do leather-bound copies and copies, and sell them on Amazon. For 100 pages. That would be the best.
It's going good.
Oh, hang on, Kash is not on mute.
Hey, Kash, it's always good.
You're not on mute.
Yeah, I was like, why am I not living here?
Uh-oh. All right. Next time I'll log in with my admin account.
Yeah.
All right.
Okay, thank you, James.
All right. Yeah, thank you.
But no, see, a serious question. Would this be better as a wiki rather than a PDF? It wasn't a flippant question.
We can do both.
Yeah, I think possible.
Yeah, why not?
Do you think have a benefit of that doing the the wiki?
Yeah, it's more searchable, accessible, and everything else. So
yeah,
and it's something that gets maintained.
Yeah,
but it's work.
Yeah, we should definitely look into that.
Okay. Any questions from anyone? Shahab, Quinn?
Nothing, thanks. Great job.
Mitch, Michael? Majid? Rajesh? Bonchong?
No, Bapi, I just wanted to make a comment, which I support what was just shared by James and David about the input output, Bapi. This is like very important for each workflow shared, especially from test perspective. It is good for porting all the chiplet level patterns, no reuse. I mean, there is a complete reuse, no regeneration. That's a very important aspect of that. Thanks.
Okay. Uh,
Yeah, I just wanted to once again thank all the authors and conclude with my initial slide. And really, this has been a lot of work from a lot of experts. So thank you, everyone.
Yeah. By the way, the name order are by the last name, so there's no particular. I think it's not like paper like priority anything like that. So it's just order by last name.
Yeah, unfortunately, James ends the last in this. So
yeah, that's what I want to explain.
yeah.
That
I just thought of a business idea where there's going to be a plugin that on every opening of a document it will randomly reorder names, so that every time it looks different and so that there's no specific order, right?
I'm definitely second to that. That's a
Yeah.
very good idea.
Right. Yeah. All right.
all right, then in that case, Boon Chong, anything you want to add? It's
No.
okay. Any other author online or say anything? All right. Hey, thanks, guys. Thanks all. Huge effort.
Thank you, Bobby, for the opportunity.
Huge effort.
Yes,
Thank
thanks.
you.
Well done. Well done, guys.
Yeah. Thanks everyone for the support.
Into the radio, don't you remember?
Hi, Paul. Oh, hi, Vijay. Oh,
Good morning, Mark. Mark,
Hi, how's it going?
doing good. How are you?
Doing well. Oh, there's a bunch of other people. Great. Hi, Boone. Hi, Trent. Hi, James.
Hey, Marit. How was your Thanksgiving holiday?
It was pretty good. Definitely glad to we got the Friday off as well, so it was nice to have 4 days in a row. But we didn't do much, just a little bit of like cooking for the day of, and but yeah, was pretty small. How about yours?
Sounds good. Yeah, yeah, kind of the same. Didn't have any. I think I wrong. I think I only travel in plane, so I think mostly just stay around and hang out with friends and family. So, but it
Okay.
was nice. I think relaxing holiday. So yeah, same we for long days. I think yeah, of course did quite a bit of shopping.
Okay. Yeah, I guess it seems like online there's just it seems like you have 2 weeks of deals now or something.
Yes, they kind of started even I think early of the week.
Yeah.
Every year it seems keep changing. It's not a Black Friday anymore.
Yeah, I know. We can see if a few more people join, but I can already like just preview there's not really too much to discuss today. I wanted to follow up on a couple of questions that we had discussed last time, but it's likely going to be a pretty short meeting. Hi, Anu. So I think one of the questions that we had started talking about last time, just in terms of logistics of how we get this, how we can publish this paper, was the question of licensing. And the initial feedback that I'd gotten from Michael Schill, who works for OCP, was that there are these there's this multi-party copyright agreement or the Creative Commons license, and the Creative Commons license looked like it was easier because nobody would have to sign anything. It would just be part of the document, and then anything within that is basically Creative Commons. The one question that we had brought up was if we went that route, what does that mean for any of the images from white papers that we're citing? And so I had reached out to Michael, I think just right after the meeting, like 2 weeks ago, and I pinged him once or twice already, but haven't gotten kind of a clear resolution whether one of those strategies is easier than the other. I guess my hunch is that maybe it would be easier to ask another company if we want to copy an image to say we're just using it for this white paper, and that's and OCP has copyright to that, and it's not just basically opening up that image as a creative license to everybody. But he wasn't able to weigh in on this or give a recommendation one way or the other. And I think the other aspect that Anu and Trent had brought up was just to check with their respective legal teams to possibly understand if one way is better than the other. So I wanted to see if you had a chance to reach out to your respective legal teams and whether there's a preference to use one versus the other.
Yeah, Mark, I did have a discussion with our one of the attorneys on our publication clearance team, and
okay,
he felt at least in the context of what I had contributed, he said if it was an NXP paper, and I was referencing a something that was already published and available to the public, it's okay just to reference it. But I had already started down the path of recreating a lot of the images, and so at least for a lot of the graphics, I was going to do that. There's a couple references to actual data and numbers, but but since it's not a graphic, it's okay. So,
Okay.
So I think that, from an NXP perspective, it is okay to reference, publications which are, available, that's been published, right? That's not confidential. But I think that probably, the LCP requirements are going to trump, whatever.
Right, but so you're saying you would be at least from kind of the choice of licensing, what that paper, like in terms of the white paper, you would be okay with either, or you and hence NXP would be okay with either the Creative Commons or the multi-party agreement.
Correct.
Gotcha. Okay, well that's already good to know, and I still hope we can make it work with you with the Creative Commons license. Anu, did you have any chance to run this by your legal folks?
No, sorry, Marek, I haven't, and appreciate that Trent actually worked on his action item. I didn't, so sorry about that.
Okay, no problem. Do you think you can still do this, say, for next week or so, or even just get the conversation started? I understand that it may take longer to resolve.
Yeah, my biggest problem is once you ask them something, they ask you 300 questions in return, of which I probably know the answers to one.
Yes.
And then
I happened to catch a guy in the cafeteria, so that's how I was able to get my answers.
Yeah, that's the best way to go, Trent. When he really wants his coffee in a hurry or something.
You have to get them before breakfast so that they just after 5 minutes they're like, okay, I really gotta go. Okay, yeah, no problem. Then thanks for following up. Okay, so I think Bapi, since you're also online, I just want to double check the timeline that we had worked out. I think last meeting or the meeting before that, which was tentative that we would do for this white paper a presentation to the general ODSA group on the 19th, then go to the server subgroup committee on the 24th, January 24th, and then do the incubation committee early February. Would that still work for you?
Yeah, well, actually it turns out that we don't need to go to the server group.
Okay.
So it'll be just straight from here, then we'd email the server project leads, and then from there go to the incubation committee.
Okay.
But what I'm realizing is that this wouldn't be a contribution. I guess we could just say it is. By the time the Chiplet Summit rolls around, it still wouldn't be a contribution, but I think that should be fine. Not a contribution, a white paper, excuse me. I don't think there's a delay at the OCP, so we should be able to. Apparently, we can also do it by email.
Okay.
With the incubation committee, if it's something we want to push through.
I see. Just to send an email and maybe have an accompanying deck or something to explain why we did this, or even some way to communicate the background of this white paper.
So, but for that to work, we would probably have to pull this forward to January 5th. Or
that's what we discussed, and I was mentioning then that I'm out until January 6th.
Okay.
Yeah,
so
exactly.
We'll stick to where we're at, and we will. We've got 3 more Wednesdays. I guess we could always do a Christmas meeting when nobody's on.
Yeah, I mean, I'm probably not a big fan of that either.
No, we'll stick to the current schedule.
Okay, sounds good. All right. Okay, that sounds good. So then that's all. Yeah, so I think between now and then, I myself was kind of wasn't able to do much more progress on the translation of things. I think text-wise we're pretty well set. I still seen Cliff was giving us a couple more notes, and I'll follow up with a few of those comments with him. But otherwise that looks in good shape, and it's just to me now busy work to basically polish it and make sure that references and citations and the style choice is all up to code basically. So that's it can take several hours for sure, but at least it's nothing unknown in a way, or so I think I'll definitely be able to get that done before the end of the year. Yeah, I think that's actually all that I wanted to follow up with people on. Oh, so I guess maybe Trent, since you mentioned that you have been redrawing some images, do you mind just giving a quick update where you stand, since you kind of have the biggest share of external images in the paper?
Yeah, I'd say I'm about 40% done.
Okay.
And I'm gonna be on some. I'm gonna be doing some traveling Monday and Tuesday this week. So I'm hoping while I'm sitting in airports, I'll finish. So I'll finish up by Tuesday, and then upload all those images to the. I actually just downloaded the paper and grabbed the images, and I'm working on them, and then I'll just upload them back into the paper that's on the Google.
Yeah, that's right. Or you can also even like send me the doc by email, and I'll put it in because I'm like in the process of translating it to this like kind of like polished version anyway. But either way, whatever works. Yeah.
Oh, all right. Okay.
Okay, that sounds good. Okay. Any other thoughts? Yeah.
I know we discussed this, but I'm sorry, I don't really remember if we have it. Do we have an intended audience section in the paper?
It's I've put it into the introduction as well as the abstract to like call that out. Like I don't have a full section on it.
That's fine.
But
as long as we have, thank you.
Yeah, no worries.
Marek, quick question. The questions that I have to ask legal, I know you said it's documented, and I think you sent me the link. So I just want to.
Yeah.
Okay. Thanks.
I can if you want I can follow up again and send it to you again. There is the OCP section that so like basically in the white paper there's an area that like talks about the license, and there is a link in that section that gets you to the OCP site and has all the explanation.
Hey, for what it's worth, I don't. My vote would be just to show them the Creative Commons license and nothing else.
Oh, I see. Okay. Yeah.
It's legal. Generally gets like if you give them two options, it's going to take 4 times as long.
Yes, I agree.
Okay, so just say like this is how we want to publish it. Just please sign off on it as fast as you can.
And then point them to an external Creative Commons license with the wiki page and everything, and say this is all of planet Earth uses this or something.
Yeah, that's true. Yeah, I mean that okay, that's a good point.
Yeah, no, easier to give one option and start, and then see what the million objections are.
Yeah.
Okay.
Yeah. And I think the Creative Commons is easier because the OCP license, the lawyers say, no, I need to review this and everything else.
Yeah. Okay.
And do we have any examples of? I wonder, like, do you guys know of any large corporation releasing a white paper under Creative Commons license? That usually makes life a whole lot easier.
Yeah, I guess I mean most of them like to keep them behind this like sign up wall where you have to like then get their emails, right? So
yeah, but that's still the licensing is different from access, right?
Oh, I guess that's true. I mean, I'm not sure about the one white paper from the CDX group that like I know Siemens had that like the white paper about the chiplet standard recommendations on chiplet standardization. Like I know they had that behind like on the Siemens website. You had to like kind of give all your contacts and then they would give you the link. But then I'm not sure like since it was OCP work if the document itself is actually available like as a Creative Commons document. But maybe James knows.
That usually becomes easier to show to another company, like if Intel or somebody related release something under Creative Commons, you just sort of say, look, it was good enough for Intel.
Yeah, but then I guess there's no real point for a company to do that when the other one is so much easier and you just have more control over what you published.
Yeah.
So I think I'm not sure if there are like I also been helping with like a white paper from the GSA, and I think they are not using Creative Commons, but like that was the other like I guess organization that I could think of that also has basically industry participation, but then it's independent of each company. I mean, the other probably best reference case is the previous business business group chiplet white paper, and I think that had like I was scrolling down to the bottom of that to see the licensing, and I think that certainly also had the paragraph of the Creative Commons in there.
Okay. It would okay, I'll go hunt for some. Then it makes selling it to legal much easier. But mostly Intel always puts everything under copyright Intel, so there's that.
Yeah. I guess Anu, can you just argue and say like you've done this before and that information's out there, and so you should be able to do it again.
Yeah. I hope I have the same luck Trent had. So
Yeah. Okay.
You need to befriend the attorneys, Anu.
oh my God. My wildest dreams.
So, Papi, are you suggesting that OCP also open to other format other than the common creatives or other licenses?
No, OCP is open. There are two options. I think you can all sign a collective license agreement, some kind of a release.
Yep.
That one and versus a common Creative Commons, right? But not other type of the kind of like common license, right? Other than Creative Commons.
Wait, I'm lost, James. I'm sorry.
Yeah, I'm talking about Creative Commons license.
Yeah.
It's kind of one of the public copyright license, right? I'm just thinking about there may be some other public copyright license.
No, this is just in terms of purely selling it to your own legal. It's much easier to, if you have precedence of saying, hey, this large corporation released it under Creative Commons, so we should be okay with it too.
I see. Okay, I'm just thinking
Nothing
about
else.
like maybe there are some like GNU, GPL, those kind of things, right? If there's something easier to sell, do you think that some OCP may be open to that?
No, I think we can't change OCP's license. It's more entirely in terms of selling it to your own legal department.
Okay, that's what I want to verify. It's only just a Creative Commons, but either that versus the signing that release. Got it.
Yeah, so I can just put this link in here and maybe share my screen just to show what OCP has, and then you can read up on it more.
No, I think I've seen that before. I'm just kind of curious.
Yeah. Okay. Yeah, but
there's could be an option that maybe you can use like GNU, GPL, right? The GNU is just another kind of like
that's true.
Public licensing.
And I'm not sure if GNU was the one where you had to attribute at least to like where you got it from, whereas I think Creative Commons is just you don't even have to reference it, or I mix those up a little bit.
Yeah, I'm not quite sure. I think I've seen that before, but I haven't got into that window. I just thought that if that option available, maybe you can go back and revisit and compare the both and see.
Yeah. Are there any other questions about the white paper?
Nope, thanks.
Okay. Then I'm happy to just like leave it there for today and give people back a little bit more time off their Friday, unless somebody else wants to talk about something else.
That's good.
Thanks, Mark.
Okay, no problem. Thanks, everyone.
Yeah,
Bye.
Thank you. Bye-bye.
Yeah, bye-bye.
Bye.